Welcome to Simcast, a podcast brought to you by the Society for Imaging Informatics and Medicine.
Greetings, Simcast listeners. Today we have an episode that I've been excited for a number of years, and we finally managed to catch up with our guest and have an amazing chat that I know you will enjoy just as much as I enjoyed interviewing him. So our guest today is Sébastien Jodogne. He is a computer scientist specializing in health informatics with expertise in software engineering, computer vision, clinical interoperability, and medical imaging. After earning a PhD in reinforcement learning at the University of Liège, Sébastien worked as a research engineer at EVS and Eurosys, followed by postdoctoral fellowship at the University Hospital of Liège. His research led to the creation of SNMIS, the first spin-off of the University of Liège. He served as the chief scientific officer, and he also worked as a project manager at WSL and adjunct lecturer at the University of Liège. In 2021, he became assistant professor in the Department of Computing Science and Engineering at UC Louvain, founding the Medical Informatics Laboratory, which now includes 7 PhD students, 2 postdoctoral researchers, and 3 research assistants. Sébastien is a well-known figure in the community for the creation of Orthanc, a free open-source ecosystem for medical imaging that has made a significant contribution to the interoperability of DICOM images across healthcare systems. The vision of Orthanc project is to share technical knowledge in medical imaging at a large scale, including in the field of artificial intelligence. Scientific collaborations are also underway to adapt Orthanc to applications related to industrial computer vision and cultural heritage preservation. Last but not least, Sébastien advocates for the use of free and open source technologies in healthcare to improve knowledge sharing, development, cooperation, and innovation. His team is involved in numerous research projects aimed at building bridges between medicine and artificial intelligence. These projects include natural language processing for clinical language, automated analysis of mammograms, numerical modeling of tumor growth, deep learning for electroencephalography, and computer vision for computer code reading. His team also works on the design of software for teaching medical informatics, as well as platforms to collect and analyze clinomics and genomic data from healthcare information systems for research purposes. It goes to say, Sébastien has a lot of interesting things to say, and this is definitely one of our very information-rich episodes. So I hope you enjoyed it as much as I enjoyed interviewing Sébastien. Hello, Simcast listeners. I'm sitting here with our mutual friend, Sébastien Jodogne. We've been wanting to record this episode for a very long time, but just our schedules haven't really figured out each other until now. So this is an episode I would say is at least a few years overdue. Without further ado, Sébastien, I have a lot of questions for you. But I'm actually curious, how did you get your start in imaging informatics? Was it something that you aspired to or just random?
So actually, I've not started working directly inside the field of medical imaging because I was rather working during my PhD in the field of computer vision. I was trying to combine reinforcement learning with computer vision. So that was quite a difficult task at that time. It was at the beginning of the 20s. And so, yes, I've been working a lot in the field of computer vision, notably in industrial vision. And then by the beginning of 2011, I had the opportunity to do my postdoc actually by a hospital, the University Hospital of Liège, where they wanted to hire a medical imaging engineer. And that's why I started working actually in the field of medical imaging. So I was not immediately active in medical imaging. It took some years in order to start it. But now I've been working on it for more than 15 years.
So you stumbled essentially into the field by coincidence.
Not really by coincidence, I would say. I had always liked this aspect of healthcare, and it was quite difficult to find a job that was both scientific and related to healthcare in Belgium. So I had this great opportunity, and it was wonderful for me to start working by a hospital with real-world physicians, medical physicists, and so on. So I learned a huge amount of stuff by doing this clinical research inside the hospital. And that's really why I started the project Orthanc that we will cover in the future.
That's exactly what I was going to ask next. So take me to how that led you to starting Orthanc.
Yes, so it started really because as I was hired by the hospital, there was a need to first do artificial intelligence already at that time. It was something that was growing in interest. But also we had some very practical difficulties at that time because we had, for instance, some difficulties in connecting the nuclear medicine departments with the radiotherapy departments. And so there were images that got lost between the two systems because there were some resets in order to avoid buffer growing too large. And so I wanted at that time to create a buffer, basically, between the two departments. And Orthanc really started from this fieldworld need. So it was a very focused need to make the communication between two departments more smooth. It evolved in a large-scale project over the time.
I mean, obviously, fast forward to, modern day, Orthanc is one of the biggest open source projects that enjoys a lot of usage from people. But I'm actually still curious about the origin story in this case. So in your case, early 2000s, there would have been options like DCM for Qi at the time that existed or XNet. What made you decide, no, I'd rather just build my own?
So at that time, it's not true anymore, but at that time, there was no really REST APIs actually for medical imaging. So basically, this was one of the things that triggered myself. I asked myself why we still had to stitch to old communication protocols, to reinvent the wheel every time we started a new application for medical imaging. And so I felt like at that time, REST APIs could be quite a good approach for medical imaging. And actually, this was during the process of standardization of DICOM Web. It was maybe 3 or 4 years before the introduction of DICOM Web. And actually, Orthanc became the first open source implementation of DICOM Web. So that was really something I think that was important in the history of Orthanc. And maybe another aspect is that at no time I wanted to create a hospital PACS. That sounds maybe a bit strange to say this, but my objective at that time was rather to create an ancillary PACS. So the idea was not to replace the PACS of the hospital by an open source solution, but rather to provide a way of deploying task-specific mini PACS, I would say, around the main PACS of the hospital. And I think those are the two main insights that brought me to Orthanc. This REST API aspect with microservices and so on, and also this idea of not focusing on one single big PACS, but rather to think about DICOM server that could be deployed in many places inside the hospital, and to make sure those individual instances could solve tasks that are related to one department. This is, I think, the key distinction between DCM4Qi and Orthanc. I'm very happy to use DCM4Qi, actually. I use it in some of my projects. But really, Orthanc was more, at that time, a prototype to create really a lightweight PACS that could be used in another way than the main PACS.
Yes, and lightweight for sure. It is still to this day is very easy to run. One of the quickest ways to get started with anything is to run with Orthanc for sure. Yes. You're touching on so many topics. I'm going to go on so many different tangents, but one of the first things I wanted to ask you is when you started in medical imaging and started working with DICOM, what was your first impression of DICOM like at the time?
Actually, I liked it. It's maybe strange to say this, but I liked the aspect of one single standard that is shared by so many people around the world. I think it's quite unique in the field of health informatics, and that's what something I found extremely inspiring. So it's true that it was something that was developed in the 80s. So maybe to new developers, it could look maybe a bit outdated, but actually it's so robust and so well defined and so widely deployed that it's something every computer scientist dreams of. This is very rare to have a standard that is so widely adopted and that is so well crafted. So there are not that many examples. JPEG is maybe another example, PNG too. TAR, ZIP. So those are really generic, I would say, file formats. But even when we go to the ODT, docx file formats and so on, I find that they are less robust, I would say, than DICOM. I like this aspect of something that is extremely well defined and that has a long experience with real world data. And I also liked the fact that it was a standard that was developed from the start in an open way. I feel like the people who designed DICOM in the first place were extremely well, I would say, visionary actually, because nowadays it's quite obvious that we need to define standards in an open way. But 40 years ago, it was not that trivial. So really, I appreciate this visionary aspect. And from the aspect of something that might seem a bit, I would say, outdated or oldie from the perspective of a newcoming computers engineer, I would say that it's not something that it's very important because we do have a lot of people who have worked on open source implementations of the standard. And I don't think it is something that should stop the people from using DICOM. Really, it's so well conceived that I don't see any alternative right now for replacing DICOM. And so that's maybe something that I would like also to say in this conversation, that I am extremely grateful from the people, for instance, behind this MTK, so the people from Office who built the implementation that is nowadays extremely widely used to parse DICOM instances, to send DICOM over the network. So this MTK was really an extremely important project, just like DCM4Chi, the library, because I also use this software library to test my code against. And PyDICOM and PyDICOM.net also are extremely important projects. So this is not only about the standard and the people who use the standard in hospital, it is also a vibrant community, I would say, of open source developers and SDKs that allowed all of this to happen. And it was not that clear at that time, but over the 10 last years, I felt like I found it extremely important to see so many open source viewers that emerged. So notably Chris Haffey with Cornerstone that gave rise to Cornerstone. Wizis is also an extremely important project, 3D Slicer. So yeah, a huge community that is also providing tools not only for developers or clinical environments, but also for real-world physicians, radiologists, and so on.
Yeah, you're absolutely right. And you're touching on so many great points. For a community that's relatively small in size, the imaging informatics community is, I think, punches above its weight as far as open source software availability. You're right, there's so much great software out there in this community. You have sometimes maybe even too many choices for when you're trying to set out to do something.
And I think it's extremely positive to have the choice. I don't think it is a competitive environment in the business way of saying things. It's rather something where you have an innovation in many different aspects. I feel like all those projects are extremely well positioned and are not that concurrent because we have I think, now worked on clear separation between the different projects. And I feel like it is also an extremely important aspect in the open source landscape around medical imaging is that people really collaborate. All those tools are useful in a way or another, and they are unique in some aspects. So it's not clones or forks. It's really something that where we see that people are working in complementary ways. And I think it's also something that is extremely positive in this community.
Yeah, absolutely. And I was going to say that in this case, the relationship between the different packages, I also find to be generally complementary, where they're feeding each other in a way. In addition, the way that these things fit together, almost like building Lego blocks, you can build so many really cool, crazy things on top of these things. And it goes all the way from enabling healthcare in low resource settings to enabling some of the most advanced, most technological, cutting edge applications and medical imaging. It is really, really impressive. Your point about DICOM is, of course, another one too. I often talk to a lot of people who are new into the industry, and I help kind of introduce them to, okay, here are the foundations of imaging. And that's one of the big bragging points about DICOM is it's the one standard that is backwards compatible all the way back to the 90s. You can't say the same, for example, for the HL7 suite of standards, right?
Yes, that's true.
Yes. And often when I teach people about these things, one of the things we also talk about is when people say HL7, most people are thinking about V2. And then there's, of course, Fire. But a lot of people forget that in between, there was a version 3. And version 3 failed. And it failed for many reasons. But one of the reasons was the lack of tooling. It came out and there was just not tooling around it, right?
Yes, and maybe also the over-completeness, I would say, of the standard, where everything was extremely well documented, with few possibility to do some extensions and to work on the edge. And I think that's why Fire is driving such a large community right now, because it's really, I have the hope that Fire will really become the DICOM for health data that we missed for over 30 years. So I am extremely convinced by this new standard with tools like Happy that emerge and that allows implementations. And that, for instance, that's something that we published as scientists. I wrote a paper about how to turn Orthanc into a Fire server, which was an illustration about how medical imaging can get closer to the electronic health records thanks to using new interoperability standards.
I remember that paper. If I remember right, it was called PACS on Fire, right?
I think the title was Setting a PACS on Fire.
Yes.
That was the exact title. That's why that was just...
And for the listeners, Fire in this case is spelled F-H-I-R. It's the standard Fire, not, the fire where you call the fire department, just in case anyone didn't know. This is awesome. Fast forward to the future. So you created Orthanc. It's been, a decade or more now. What are some of the things that you look back in your journey that you find are most satisfying, you're proudest of? I mean, obviously there's a lot, but, highlight.
That's a difficult question, evidently. So first, I think that the thing that I am probably the most proud of is that a lot of people learn at DICOM by using Orthanc. I feel like Orthanc can be used as an educational tool for newcomers. I think this is a distinction between Orthanc and, for instance, DCM4Chi, which is an extremely wonderful piece of software, but that is much more difficult to use on a standard laptop because there are a lot of steps that you need to do in order to set up your database, to configure your system. With Orthanc, I always wanted this approach of it just starts out of the box. You just install the package and it will work on any type of computer. So right now, for instance, I still test Orthanc when I do a release with Windows XP, for instance. So I know that right now Orthanc is still working on such an old operating system, which is still in use in emerging economies. So
Yeah.
you will see a lot of Windows XP outside of Europe and US, basically. I feel like it's important. So this is one thing I'm proud of, that Orthanc is used by many people to learn about medical imaging. And maybe the second achievement is the community, because right now on the forum, we have more than 1,000 people who interact with the developers behind the Orthanc. So it's quite nice. It's very hard, actually, also, because we have a lot of people with huge gaps between their technical knowledge. So driving a forum with people who are not that familiar with DICOM is something that is very tough and maybe also exhausting for us to manage. But still, those 2 points are really important for me. First, this educational aspect, and second, the community-driven aspect.
Yes, absolutely. And I definitely vouch for both, especially the first one, because as I said, I sometimes talk to people who are new in the domain, and the first thing I usually tell them is just go run Orthanc. And they're like, oh, how do I go about so? I'm like, just go read the documentation. You'll be surprised how easy it is. You don't need to think twice about it. It just works. Yes,
Thanks for the feedback.
it's true. It's absolutely true. What are some of the coolest things you've seen people do with Orthanc?
That's a tough question. I think that what's the most important to me is to learn that some clinics in hospitals, maybe not in US and Europe, use Orthanc as their main PACS system. This is something I am really proud of, because we have a huge amount of people in economies that do not have the same chance as ours to have an access to medical imaging that is as smooth as possible. So that's this aspect of knowing that Orthanc is used in Africa, in Brazil, in Asia. So it's really something that I find it extremely important. And also, another thing that surprised me is the number of companies who know Orthanc through their development teams. So it's true that often I have contacts with companies who say, hey, my R&D engineers know about Orthanc and we use it to do this. Even if it is to prototype, I have the impression that Orthanc is quite widely used in the industry, notably to create, I would say, bridges between hospitals and, for instance, deep learning models. So I know that a lot of people are using Orthanc as a kind of a gateway running inside the hospital that is agnostic, that is vendor neutral, in order to send the images to their cloud platform. So this is actually a project that grew lots beyond what I intended to do in the first place. While I wanted to have something that was usable to smooth some workflows inside my hospital, it grew into something that is used in the industry, in the education, and in emerging economies. So this is, I would say, something that is important to me, and that I find especially cool.
And it is also very cool as a fan and user of Orthanc to see the evolution. And I feel like at least once a year, I will go on LinkedIn and I will find that you announce something that pretty much, I fall off my chair kind of thing. So it's really cool to see the evolution and like all the new things that are happening. So I remember the first time when you announced that you were baking the OHIF viewer, which I'm a huge fan of, into Orthanc. Again, it was a moment where I almost fell off my chair. Like, okay, this is, one of the best things to have happened this year.
Thanks for the feedback. And that was indeed my point of view. The difficulty with this is that we had a lot of demand of support because we were a bit at the the interface between the PACs and the viewer. So
Yeah.
who needs to fix something? So the OHIF developers really helped us, and I think that we also helped them to reach a wider audience. So it is really something that was extremely beneficial between the two communities.
Yeah, for sure, 100%. And I will tell you, I'm friends with a number of people in the OHIF community, and we have a joke in that community that if you go to a trade show like RSNA or something, we play the game of you walk the aisles and you count how many companies are using the OHIF viewer. Now, of course, it's easier. A lot, definitely a lot. But in the OHIF viewer world, it's easier to see it because obviously it's the viewer, it's the front end. But I also bet you that for any one of them who's using OHIF or got anything else, there's a good chance they're also using Orthanc behind the scenes to, store their DICOM images, serve their DICOM images. So it just goes to show the extent of how much of a difference these open source projects make in the industry. I'm obviously very passionate about this myself, and I try my best to talk to my friends and educate people about what it means to use open source and why open source, more often than not, isn't just an afterthought. It actually should be your forethought. And again, Orthanc, OHIF, these are really good examples. But we were talking about the surprises that you drop every now and then. Most recently, you dropped the educational plugin. I've had a chance to take it for a spin. I want you to describe it to the audience, if you don't mind.
Oh, wonderful. If you can do some preview of the project, yes, it would be wonderful for us.
Do you want to tell us a little bit more about it? And then, I can add some links to the podcast episode.
Okay. So do you want me to explain what it is about?
Yeah, it's just a high level.
So yes, actually this education project started, I would say, 2 years ago, because we wanted to have a platform in order to teach whole slide imaging in the context of digital pathology. Because right now, people in the education still need to have physical microscopes in order to see the glasses with the tissues, the samples. And so evidently it is not scalable because you need to have the glasses, you have to have the microscopes. People cannot see the images outside of the professional environment where they have the special access to those facilities. And so we wanted to create a virtual microscope. This is something that already exists. There is a lot of different tools to do this, but there are few of them that are integrated with DICOM. But Orthanc was actually one of the first implementation in open source for whole slide imaging. So it was something that was released, I think, in 2017. So I told my university, hey, it would be cool to use this knowledge to build something that will be useful in our educational cursus. So we wanted really to create a virtual microscope and to give it to the students. And so we had all the tools at our disposal. We had the implementation of whole slide imaging as a plugin inside Orthanc. We had the DICOMizer, which allows to convert from any proprietary file format into the DICOM file format. Even if it is something that is not widely supported, we have the open slide library, which allows us to easily access images from vendors that will with proprietary file formats. So that was really cool. But what we needed was to have an interface in which the educators could create collections of images and upload DICOM images and then select those images as subparts of a collection, and then have a way to say, I want to publish those collections to a subset of selected students. And so this was not really a project about the technical implementation, I would say, of a virtual microscope, because we already had all the building blocks necessary, but it was rather talked as a project for system administrators, for educators, and for students. So it was not about the file format and about the DICOM protocol or stuff like this. The idea was to create an administration platform that allowed us to manage a course or a set of courses. And so this all started like this. And during the last academic years, we built the software. And during the months from February to May of the last year, we deployed the first prototype of this tool, and it was evaluated by more than 300 students. And those students had access to our collection of all slide images at the University of Louvain-la-Neuve. And it was about, I think, 120 slides that was used to teach histology to those students. And so next we had the intuition that this virtual microscope is very nice, but we could still do better because there is no need to stop at slide imaging. We could also go beyond digital pathology and to teach medical imaging in the large sense. And so we expanded this prototype in order to have not only the students, the instructor managements, but also the possibility to create links with all the web viewers that are integrated within Orthanc. So we have the whole slide imaging viewer, we have OHIF, we already talked about it. There is also Kitware VolView, which is quite a nice piece of software to do volumetric rendering. And we have the Stone web viewer that I personally develop as a teleradiology solution. So we wanted to enlarge the project, and this is exactly what I've been working on during last summer. And we also wanted to have an integration with Moodle, so a learning management system, which needed to implement another kind of network protocol that is called LTI, for Learning Tools Interoperability. And so this was what I've treated over the last few months, and it was released in, I think, the beginning of November, something like this. And now our project is to bring this educational platform to our institutional servers and to create a large-scale deployment for many courses in our university where we deal with medical imaging. So we wanted to have a fully sovereign platform that could allow us to publish DICOM images, either for radiology, MRI, CT scans, so on, all slide images, to students and to interface them with Moodle. So this is really the next big step right now. It's to have this deployment. Right now we are in a prototype phase that is limited to digital pathology. And I hope that we'll be able to expand this to other courses for the next academic year.
It's amazing. And obviously, I took it for a quick test drive when you announced it. For anyone listening, if you're curious, highly recommend you take it for a test drive. It's very, very easy to get it going, very easy to set it up and have it running. Now, that being said, we've talked a lot about Orthanc, and I'm sure Orthanc is a very big part of your professional daily life, but you've obviously got other things going on. So my question to you is, tell us about what else are you up to these days, your research interests, anything else you like to do during your day?
So yes, that's true that it is evidently not my whole life. I think I have a lot of things. I have my personal life with my family. That's the first most important things. But as far as the professional stuff is concerned, I am an assistant professor, which means that I have to give courses, I have to manage a research lab, I have to do research, and I also have to do some services to the community. So it means that this really goes beyond Orthanc. And at this point of the conversation, I think it is important to mention one of my friends who is a close collaborator, Alain Mazy, who is the other big contributor to Orthanc. And it is also thanks to Alain that I am able to manage this large-scale community. So first, thanks to Alain. That's the first thing I wanted to say. And so to answer more precisely your question, so I have about 6 courses. So I have to teach 2 bachelor students in computer science and in engineering for software, computer software. So I have about 6 courses, and I have a laboratory with now about 12 members. So we are quite active, not only in the field of medical imaging, but also in the field of health informatics, more general, and also in the natural language processing domain. So we do a lot of things beyond DICOM. And actually, it's really myself and maybe one of my researcher, Edouard, who are the most active in medical imaging, but we have a lot of activities on the site. So, for instance, what I'm currently developing is it should probably be the next big step for Orthanc, is to propose an infrastructure, a new plugin that would allow us to easily interface deep learning models with Orthanc, because right now we have still this difficulty in teaching deep learning for radiology to physicians or to software engineers. We have a huge amount of different models that are available on Hugging Face, Kaggle, GitHub, and so on. But still, it's not easy for the people who are not familiar with deep learning to run them, because you need to have some knowledge of Python. You must be able to install maybe CUDA on your computer. So it is not something that is trivial for people who are not computer scientists or software engineers. So this is one of my goals now, is really to bring deep learning closer to Orthanc. That's one of my important projects. Regarding the other projects I have, it's also to create what I call a hub that would allow people to easily exchange images between different sites without having to set up point-to-point connections. Because right now, when you have different researchers that who are trying to work on a set of clinical cases, it's quite hard to have these exchanges as soon as there are more than two persons who are trying to exchange the images. So this is another point I would like to tackle. And maybe a third point is the bridge between the neuroimaging community and the radiology community. Because right now, if you go into research, you will see that a lot of people use Nifty and probably BITS as their main framework. And so we have a huge amount of different tools that are able to convert from DICOM to Nifty or to BITS, simply because those file formats are easier for computer scientists or for researchers to play with. But we break the link between the patient, I would say, and the image. So I try to smooth this conversion in order to make sure that there is always a link between the DICOM and the BITS file. And it is the third, I would say, hot topic from my perspective right now.
Very nice. Thank you. That's a lot of interesting research that's going on. Now, one thing I meant to touch on and almost forgot is a message to the listeners that there are multiple ways you can show your support for open source. I'm going to name some of the ones I've thought about before, but I definitely want you to weigh in here. So obviously, being an active user goes a long way, but do take the time to spread the word about your favorite open source projects. Tell people, educate them, show your support publicly. So, post on LinkedIn. If it's a project that's on GitHub, make sure you go and star it. These things go a long way. Be involved in the community, whether you're helping report bugs or answering questions from people on the forums. But a couple of things that people don't think about often enough is that with open source, donations go a long way. And Orthanc is an example. They take donations on Open Collective. So please, if you are a fan of Orthanc, you've used it, you've benefited from it, and you've got some money to spare, all donations go a long way in sustaining this very, very important project. It's central to the medical imaging community these days. Another way that you've pointed out to me a few years ago that I actually didn't know about before is people like Sébastien are academics, and the currency of academia happens to be papers. So when you're writing research papers that have used open source tools, try your best to cite the original authors, because that's one way of essentially, giving them a nod and giving them recognition for the hard work that they've done. And, these are just some basic ways people can support open source. Unlike what a lot of people think, you don't have to be a developer and don't have to contribute code. There's a lot more that everyone can do to contribute to open source. Was there anything else that you wanted to add in that avenue?
I think it's a very important message that you have just given, because it's true that if we don't have the citations or if we don't have the papers, then we will not be able to the system in the long term. So I would say, as I told you, we have actually two different structures around Orthanc. We have the academic world with myself, and we have the business world with Alamazi. Alamazi, for instance, is extremely dependent on the donations. This is not my case. My personal case is not really about the donations. It is more about the citations, because if I don't get citations, then I will not be able to request grants. And so it is extremely important for us to grow this way. And I would also say that it is important for us to know about the use cases of Orthanc, because often people who use an open source project forget that there are behind this project people who give their time and don't have any feedback and any idea about what their project is used for. And if we don't know what the project is used for, we cannot drive in an easy way the future evolutions of projects. So it's maybe also an important thing. Even if I know that Orthanc is widely used, I don't have any figure to show, because people often prefer to keep secrets the fact that they are using an open source software. Or maybe they don't want to keep it secret, but they don't know how important it is for the communities to know that their project is being used. And this is not limited to Orthanc. It is really a more broad message, I would say. It goes clearly beyond Orthanc.
Yes, 100%. I think sometimes people will use something like Orthanc or OHIF and whatnot, but they don't necessarily think that whatever they're doing with it is novel, so they're not necessarily going to advertise it. But yeah, you're absolutely right. Like, whenever you're using something like this, just reach out to the community, say hello, and say, here's what I'm using your software for, and you don't have to be the judge yourself of what if it's novel or not. It still is interesting to the rest of the community. It shows numbers, shows engagement, and sometimes, we tend not to think of whatever we're doing as cool, but someone else thinks it's really, really cool. So it's just different perspectives on life, right?
That's really important for us, yes. And another thing that is important is to know that communities are driving software who are used by thousands of users. And so people think that they just have to ask their question on the forum and to get an answer. But the fact is that if we spend time answering other people, then the project doesn't evolve. So it is important to know that when people ask questions, then it means that we don't have this time to develop or to maintain the code. So it is important for people, one, to try to learn by themselves and to try to ask as few questions as possible. And two, it is important to have people in the community who help others and not just the core developers. And it is something that is still difficult in the case of Orthanc, because we see a lot of beginners questions where people are sometimes a bit unspecific about their questions with just copy paste from ChatGPT or stuff like this. And we have to understand by ourselves what is the real question between this question. So this is something that people are not aware of. If we ask a question, if someone asks a question to a community, this, in the case of Orthanc, represents a work for the core developers. And this is also something that is a big difficulty in the open source communities. We are not large. We have a large community of users, but we have a small community of developers. And so this is something that is difficult to manage with Orthanc.
For sure. I believe that concern is shared across some other open source projects. I know my friends in the OHIF community have a similar issue along those lines as well. It's just hard. It's not easy to manage for an open source project. Would you say that the advent of LLM tools like ChatGPT has made it a little bit easier for the community in this case to find answers and figure out issues, or you feel like it's made it worse? Or maybe neither?
That's a good question, because in the forum, we only see the bad examples of ChatGPT. It is often the case that ChatGPT hallucinates some options that simply don't exist inside the configuration file of Orthanc. So ChatGPT imagines new options that we could implement if we had time, but and so the question is badly formulated, and this represents a huge cost for us because ChatGPT makes things worse on some questions of the forum. Still, maybe we have a lot of users who use ChatGPT in a positive way, and we don't know about them simply because ChatGPT has answered the question in place of us. It is certainly the case. So I would not say that it is black or white. I think it's really a gray. I think that we gain some stuff on the one side and we lose on the other side. But it is really, I think, a matter of behavior of the people on the forum. Because if people tried to have some empathy with the developers, it could be much more manageable. Because I think that people, they have one question, they post the question on the forum, even if they will not contribute or if they will not help us in any way. They consider that because the project is open source, then they can use it, and we should provide them with free support, which is certainly not the case. It is not because we are doing something in open source that we can provide free support for each and everything. And I would also like to explain why I decided to use this approach of open source, because we all know that basically the nowadays answer to why people are doing open source is maybe a kind of getting some reputation, or maybe to showcase to a future employer what they've been doing inside some company. So those are very valid reasons. I certainly don't say that it shouldn't happen. But in the case of Orthanc, it was not our philosophy. Actually, it was not my personal philosophy. My personal philosophy was that it is important to share knowledge, so to share technical knowledge about medical imaging to a wide audience. And it is something that was very difficult when I started the project. And so that's why I'm not considering myself as a pure open source player. I'm more in the philosophy of the free software movement. So I like to emphasize in my discussions that Orthanc is not an open source software, but it is a free and open source software. So because my personal philosophy is that we still have a thing to do in order to make sure that medical imaging is freely accessible to each and every people in the world. And that's why I like this free software philosophy. That's also why I think that we have some impact to keep in mind on the emerging economies like Africa, South America, and so on. So I think that we have this responsibility to make sure that every people in the world know about DICOM, including patients, because it is really something that is quite opaque from a technical point of view. We are experts, so we know what we do with DICOM, but it is important for patients. I've been in contact with a lot of patients when I was working in the University Hospital of Liège in the radiotherapy department, where people had difficulties in understanding why they needed to do images. And this is something where open source software could be useful to share with patients tools that allow them to understand what is their treatment and what is the reasons for their treatments. And actually, we have done a publication on this. It was a project where we showed the patients their image with radiotherapists. And we also provided the patients with a USB stick with their own medical images. So the idea was to give them, if I speak more like a technical guy, we provided them with a DICOM CT plus a DICOM RT dose plus a DICOM RT
Structure.
Yes.
Yeah.
And so they were able to have software for Windows that was built using the same technology as the Stone Web Viewer, and which allowed them to see their own images. So it was a pilot study that showed quite good results in which the patients were quite interested in knowing more about their own treatments and their own body. So I think this is also something that is important when we do free software. It is to think about the fact that it is not just about technology, about industry, about hospitals, but also about education, about patients, and about the digital divide, basically. I feel that it goes beyond pure technological stuff.
100%. And the example you gave is one that's near and dear to my heart. I'm also very, very passionate about patient engagement, patient empowerment. That goes a long, long way. Now, I knew we were going to have this problem. The hour flew by so fast. There is so much more we could have talked about. But that's all to say that we'd love to have you back on the podcast sometime soon when your time permits. Of course, being very respectful of your time, because I know you have a million things going on. Always great talking to you, whether via email or in person or on Zoom. Always fun talking to you.
Thank you very much for the invitation, and I'm pretty sure that we'll finally meet in person because it will be nice to see each other.
Absolutely. All right. Thank you so much.
Thank you for the invitation, and see you.
Bye-bye.
Simcast has been brought to you by the Society of Imaging Informatics in Medicine. Please visit our website at siim.org for more information and educational content, including webinars and an archive of prior episodes. Please follow us on Twitter at sim_tweets. Thank you to our listeners for your continued support.